What we're talking about today is writing an equation of a line and working with equations of lines. So there's two main ones that we have, and this third one is just using some other formulas to get to the other equation. So the first one is point slope or point intercept form. Given a slope in the y-intercept, we can write it in point or slope intercept form. Well, the main reason they call it slope intercept form is, well, in this equation we have the slope and the y-intercept. So it's in a slope intercept form. And that's the one that y'all have used before, y equals mx plus b. Now the other one is, given the slope and a point, we're going to use point slope form because we have a point and a slope and we plug it in. We plug in the point in y1, x1 will be the coordinates of the point, whatever point we're given, and m is the slope. So we can plug it in there. Now the last one that is listed up here, given 2 points. Now there is some textbooks refer to a 2 points equation, but really all it is it's taking the slope formula and just plugging it in for m. Now this equation here you don't need to write down because it's not really helpful, because you might as well just plug in, bless you, the points to find the slope and plug it in for m. Because this equation here has a lot going on, you're better off just using this equation to find the value of m and then just going back to our point slope form, because it's the same thing. They just plugged in the equation for slope in for m. So it really doesn't add anything to it. It just makes the equation just a little more complicated. Any questions on this so far? Let's look at our first example. Finding the equation of a line. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,200 miles of Earth on February 2013. In February 2013. About how long does it take the asteroid to travel that distance? So before we figure out the second part, first off, we need to write an equation of a line and then interpret the slope. So if we look at this here, do they give us the y-intercept? They give us the y-intercept for this here. Okay, and what would it be? Our value of b would be 0. Because if they give us a spot where the value of x is 0, that's where the y-intercept is. The value of x is always 0 at the y-intercept. Okay, we have that. Now we just need the slope. So slope is our y2 minus y1 over x2 minus x1. Or we can consider it the change in y over the change in x, or it is the rise over run. So looking at this here, how far does it rise? How far does it go up? And how far does it run? Yeah, because we can use the 24.5, the point 524, not 24.5, 524 and 0, 0 if we wanted to in the formula. Because we can say 24 minus 0, well, that would be 24. We can also do 5 minus 0 in the bottom, and we would just get 5. So we have the slope as 24 over 5. Any questions on this here? Now we can plug this into our equation y equals mx plus b. Now our slope would just be 24 over 5. And the value of b is, well, you don't even have to include it because plus 0 doesn't add anything to the equation. So the equation for this line is y equals 24 over 5x. So this right here is the equation of the line. Any questions on this here so far? So we found the equation of the line. Now we need to interpret the slope. So interpreting the slope is really telling us, or kind of explaining what the slope is telling us. So the 24 over 5. 5 is in reference to time, and 24 is in reference to distance or miles. So we could say for every 5 seconds, it travels what? That's it. That's all we have to do for interpreting the slope. We're just trying to explain what the slope is telling us. So for every 5 seconds, it's traveling 24 miles. Or to put it in kind of a perspective we can think about, that's pretty much saying that it's traveling from here to Siloam in 5 seconds. That's pretty fast. So we found the equation of the line, and then we interpreted the slope. So we're almost done. We do have one more part to this here. Because after that, it says the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So we're wanting to know how long it takes this asteroid to travel 17,200 miles.
You just did divide.
Divided by what? So what variable represents distance? X or Y? So we can plug it in. So 17,200 would equal 24 over 5x. Because the x represents time. So it'll tell us what it is. So we need to figure out what value of x will make this equation equal 17,200. So we can plug 17,200 in for y and solve for the value of x. How can we do that? What would we need to do to get x by itself? We can divide both sides by 24 over 5. Because anything divided by itself is 1. Now at this point here, we can type this into a calculator. We can type 17,200 divided by 24 over 5. And if we type this in, we'll get 3,583.3 repeating seconds. So it'll take it almost 1 hour to travel that far. 3,600 seconds is 1 hour. So it's almost an hour for it to travel 17,200 miles. Any questions on this here? Any questions on anything we've done thus far? We good with this here? Yes, sir. Let's look at this next one here. The graph shows the remaining balance Y on a car loan after making X monthly payments. Write an equation of the line and interpret the slope and y-intercept. Then, what is the remaining balance after 36 payments? So there's several things we have to do. We have to find the equation, interpret the slope, and y-intercept. So we have both of those and Find out what the remaining balance is after 36 months. Do we know what the y-intercept is, the value of b? It'd be 18, because the y-intercept is any spot where the x value is 0. Did they tell us what m is? We could, well, we can't quite do that this time because our y-intercept is not at 0, 0. Because if it was at 0, 0, that would work. So this here, we're given 2 points. Yes? So we can do y2 minus y1. So I'll say 18 minus 15 over x2 minus x1. So what value of x would go first? Now this one here is really one of the few equations where the order of plugging in 2 points matters. Since we plugged 18 in first, its x value, corresponding x value is 0. It has to go first. y2, x1. Those have to line up. x1, y1 have to line up. 18 went first.
What is it? It's y1 minus x1?
So y2 minus y1 over x2 minus x1. So since 18 went first, its x has to go first. 18 and 0. 15 went second, its x value has to go second. So the way we line up the y values really doesn't matter. The x's have to correspond to it. 18 went first, 0 goes below. Well, 18 minus 15 is? 0 minus 10 is? So the slope for this here is negative 3/10. Does it come as a surprise that the slope is negative? Should it go down? Yes. Because what is this? We're making payments on a loan, aren't we? It should be going down. Should be paying it off. So our equation y equals our slope, negative 3/10 x plus 18. So we have the equation of a line. Got it. Now we need to interpret the slope and y-intercept. So how can we interpret the slope, negative 3/10?
Well, what are we trying to figure out?
So what is
36 minutes. So we would do.
So what does negative 3/10 tell me?
That is payment. Your money over payments.
So for
every 10 payments, you get rid of $3,000.
payments, the balance goes down exactly $3,000. So Caleb, why'd you say 3,000 instead of 3?
Because that says thousands of dollars.
Yeah, the balance is in thousands of dollars. The reason they do that is it makes it easier to graph this, because if we actually had it in dollars, that y part of the graph would be massive, because the amount of change would be bigger. We change it to this to go instead of thousands by denote it as thousands each one, so we can write it on a smaller scale. They do this in lots of different types of graphs. USA Today does it a lot with pictures. When they talk about graphs, they'll have it in a different notation. Okay, interpret the slope. What is our interpretation of the y-intercept, 0, 18? What is that telling us?
That's well, I guess that's telling us
Is the starting debt or balance. Is the starting balance. Last year I said the cost of the car, which could be true, but I mean, you could have put a down payment down on the car. So it couldn't be the actual value. Most of the time you will have some type of down payment. If not, it's always a good thing to have. Huh? Mm-hmm. Yeah, the more that you can put down, the better interest rates you can have over time. Or an insanely good credit score.
So, if you ever get a credit card, does that mean you'll never have sight? You won't have a credit score? Well, like, what is your credit start?
Well, you need to actually have, it's, I'll pause this for a second. All right, so we're almost done with this here. We just need to see how much is remaining after 36 months. So our y equals negative. So where would I put the 36?
Above the, what do you put it at?
So y is balance, yes?
Oh, it'd be where the,
Because x is our number of payments.
oh yeah, it'd be where the, my bad.
It'd be where the x is.
It's different because it's not the y, it's
Because here we're looking at, we're wanting to know what balance is left, how much is left. So that is dealing with y. Y is the balance. X, this time, is our number of payments. So seeing, looking at the graph and the numbers will help us see where do we put in, what are we looking for. Now at this point here, you can type the whole thing into the calculator. And if we type this in, we'll get negative 10.8 plus 18. It'll tell us that y is equal to 7.2. Really that we have $7,200 left on the loan.
yeah, screw paying that. It's like the money I made this summer.
So really what it works out for this here is you're really paying $300 a month to pay this off in 60 months, in 5 years. But really you want to get it paid off. You don't want to get a car loan more than 5 years because that, and you'll run the risk of going upside down on the loan, that the value of the car will be less than what the loan is worth. And if for some reason it gets totaled, most likely the payment out from the insurance company won't cover the loan. So then you'll still be having to make payments on the loan for a car you don't own.
Always just buy old vehicles.
It's give and take. It's give and take.
I'm not saying like old, like.
It's a lot of give and take. So any questions on this here? We feel comfortable with finding equations of lines? Let's look at one more and then we'll move on to the other type example we're going to look at today. This here, the graph shows the distance Allison hikes in X hours. Write an equation of the line and interpret the slope. And then figure out how long does it take Allison to hike 14 miles traveling at the same rate. So if we're looking at the equation, it'll be good to have the y-intercept and slope if they give it to us. And here they do, again, they give us the slope. They're nice enough to give us the slope. And, or well, not slope, y-intercept. What is the y-intercept? 0. It's still starting it off at 0, 0, which is kind of nice. Now the slope is going to be what over what? 24.5 over 7, because that's the only point they gave us, rise, run. And since we have 0, 0 as the other point given to us, because we could have put in 24.5 minus 0 over 7 minus 0, which is just the same thing as 24.5 over 7. But we can't leave it like this here, because it's not good mathematically to leave a decimal and a fraction together. Yes. It is not good to leave a fraction and a decimal together. So what we can do is we can actually type this in. The calculator will do that. It'll simplify it down. And it'll give it to you in one of two forms. It'll either tell you that it is 3.5 or 7/2. Now for most of these here, if you want to put it as a decimal, that's fine. If you want to put it as a fraction, that's fine. Especially with interpreting the slope, telling what the slope says, it might be easier as a fraction to kind of see what it's saying. Now, can anybody tell me what the equation would be? Y equals what? Because again, decimals and fractions, we don't want them together. Because we really want to get the decimal out of the fraction, even if it's in the numerator denominator, we don't like it. Essentially what that is that it's saying that we have a fraction in a fraction. We don't want that. We don't want fractions in fractions. We don't want decimals in fractions. We don't want fractions and decimals. They don't go together. We either want it as entirely as a fraction or entirely as a decimal. We want it as one or the other, not both. And again, because the y-intercept is 0, we're just going to have 7/2 x. So how can we interpret 7/2? So interpreting the slope with our miles and time. So 2 is our time, yes? So for every 2 hours, she travels 7 miles. Is it? Yes.
You said that stuff's hard and the stuff we do.
This is Algebra 1. Yeah. So we'll get into more stuff as we get later on. Yeah. Well, this content here is Algebra 1. Yeah, this is Algebra 2. This equation of a line is Algebra 1. Yep. No. We'll get into the Algebra 2 stuff here in a little bit. So the first chapter is going to be a lot of Algebra 1 stuff that we've covered. Well, we have one last thing, guys. We need to find out how long it took her to travel 14 miles.
2 hours. 4 hours.
4.
14 miles. Took her 4 hours.
Yeah, because it takes her 2 hours to go 7 miles. Double it. It takes 4 hours. To travel 14. That's it. All right, this is the last problem we'll look at today because there is part of it dealing with line of best fit, but I'm going to move that to tomorrow, and we'll deal with the graphing calculators and working with them and finding the line of best fit. And I'll talk about it more tomorrow. There's a lot of intricacies with lines of best fit. And a line of best fit is a line that closely represents the data points that they have. They show it in finances, or if you've watched the news where they give poll numbers, and they'll give a graph or just a certain graph where it has a bunch of points and data that they're referencing, and they'll have a main line that doesn't touch half of them but goes to the center of them. That's called a line of best fit. It's a way to anticipate or predict how the data will behave. Population growth. We can predict what it is, but if you notice the numbers increase for population from year to year is never the same. But we can get an idea of what it could be, not what it's exactly going to be. And that's what they call line of best fit. And we'll look at it tomorrow. But we'll look at this here first. Now, there are two prompt venues that charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at Lakeside Inn. The total cost in Y dollars for X students at Sunview Resort is represented by this equation here. So we want to figure out two things. One, which one has a cheaper cost per student? And two, how many students must attend for the cost for each one to be the same? So we're figuring out two different things. So looking at this here, Sunview Resort, how much does it cost per student? Looking at that equation. No.
What do you want to know? What do you want to know?
So looking at Sunview Resort's equation here, the total cost Y in dollars for X students at Sunview Resort is represented by the equation. How much does it cost per student? Because X is our number of students, so for each student that's added, it's increasing by a factor of 10. So for this here, it's $10 per student. Now, the other one didn't give us a cost per student for Lakeside Inn, but how can we go about finding it? Slope. So our slope formula is what? Y2 minus Y1 over X2 minus X1. So we could say 1800 minus 1500 over 125 minus 100. I just grabbed the first 2 points, first 2 sets of numbers, because it's just the first 2 sets. But because this is a constant amount, the amount that they charge per student will be the same no matter how many students. So we really could have taken any 2 points in this table, any 2 of them, and it'd given us the same value. Now we just need to simplify this here. Which is? So Lakeside charges how much per student? $12. So which one is cheaper? So Sunview is cheaper per student. Sunview is cheaper per student. So that's the first part of this question. But they are cheaper per student, but they do have a $600 rental fee that no matter how many students come, you have to pay it. So we want to see when they will be the same. So we do have an equation for Sunview, but we don't have one for Lakeside Inn. Are we given the y-intercept for Lakeside Inn? Are we given the value b? No. Okay. So for us to be able to find an equation, we can't use the y equals mx plus b because I don't have a value for b. I do have the slope, and we do have points. We have lots of points to choose from. So what we're going to use is y minus y1 equals m times x minus x1. I can use this formula to find the equation of a line if I have at least 2 points, where I have a slope and a point. Trey, pick out one of those points. Okay, 150 and then 2100. So 12 times x minus 150. So we plugged in the x and y. X was our number of students, y is the total amount. Now we do need to distribute the 12. So 12 times x will be 12x. Then we need to do 12 times 150. 0 carry 1. So 30. I think it's 1800. And it is 1800. What do we need to do next? We would plus the 2100, because again, we want y by itself. These will cancel, telling us y is equal to 12x plus, and this here is our other equation. Yes. So I'll put the names. So Lake. I'm just rewriting these so they're easier to see next to each other. So when we look at these here, we said Sunview has the cheaper cost per student, but they also have the more expensive starting value, because this one starts at 600, this one starts at 300. So one of them can be more expensive than the other at a certain point. Now we want to see where their costs are going to be the same. So we're looking for when the two y values are going to be the same. So what we can do to find that is just set them equal to each other and solve for the value of x, because we can see where they will be the same cost. So what can we do first? Because we can get x on the same side of the equal sign. There's many different ways we could do this. This is going to be one of them. 12x minus 10x is 2x. Plus 300 is equal to 600. Then, yes. Because 600 minus 300 would be 300. Let's finish this problem quickly, and then we will be done.
Divide by 2.
X would be